Let's look at this question. We are asked to calculate the volume of the pool. We're asked to find the volume. Okay, let's see how to solve this problem. We start with our solution. You already know that volume is supposed to be length times width times height. That is the formula of the volume of an object. That's how to calculate the volume of an object. Then let's look at this. This length contains uncertainty. The width also contains uncertainty. The height of this measurement also contains uncertainty. This part is uncertainty. So how do we multiply values that contain uncertainty? That is what we need to know now. Now what I need to do is I come here, the length of this measurement is given as 5.56, 5.56 plus or minus 0.04 meters. This part here is what we call the measured value. This is the part 5.56 is the part gotten from the measurement. So we write it as L sub 0. Okay, so this is plus or minus. This part that carries plus or minus is one that is the uncertainty. Is the uncertainty, which is one we are not sure in the measurement. So this is uncertainty in the length. Okay, so the same thing happens to the width. The width we have here is given as 3.12 plus or minus 0.8, 0.08 plus or minus 0.08. So this part also represents the measured value, the experimental value. So when this experiment was carried out, the value gotten was actually 3.12. So this part is uncertainty. So we write plus or minus delta W. Uncertainty is represented using this delta sign. Okay, now if we come here to talk about the height, the same thing happens. The height in this measurement, the height is 2.94, 2.94 plus or minus 0.01 meters. What does that also mean? That this part was the value gotten from the measurement. So this is the h sub 0, then plus or minus. This is the uncertainty in the height. Okay, I'm sure you are with me. I'm sure you have taken note of this. Now, there is a formula we use to find this. Now, for us to find this volume, the volume here is gotten by multiplying the experimental value of the length, which is L sub 0, by the experimental value of the width, which is the value you got from the measurement of the width, which is W sub 0, then also multiplied by the experimental value of the height, which is h sub 0. Okay, then you put the uncertainty. Now let me show you how to get the uncertainty in the volume, because this volume will also carry uncertainty. So the uncertainty in the volume is going to be the fractional uncertainty of the length, which is uncertainty in the length divided by L sub 0 plus uncertainty in the width divided by the width sub 0, then plus uncertainty in the height divided by h sub 0 divided by h sub 0, and then what we now do is to multiply this, close this bracket, and multiply by v sub 0. So I'm going to say times v sub 0. So that's what I'm supposed to have. Now please take note of this thing I've written here. Take note of this formula. This v sub 0 is actually equal to L sub 0 times W sub 0 times H sub 0. So whatever I get multiplying L sub 0 by W sub 0 and H sub 0, that will give me the V sub 0. So I will use it to multiply the whole of this in the bracket. Okay, so let's now proceed. You've taken note of this formula, so let's proceed with it. Okay, let's proceed. So my L from this value, L sub 0 is 55. So I'm going to have that my V sub 0 is actually equal to 5, is 5.56. 5.56 times, so the W sub 0 we have here is 3.1, 3.12, sorry, 3.12, 3.12, okay, times the H sub 0 is 2.94, 2.94. And if you multiply this, you're going to have 51. So if I multiply this, I will have 51. Okay, 51. So our V sub 0 is 51. The next one we're going to do is to solve this part in bracket. So to solve this part in bracket, I'm going to have the uncertainty in the length, which is letter L. The uncertainty in the length is 0.04. 0.04. So I divide 0.04 by the measured value of the length, which is 5.56. So plus, what I'll now do again is uncertainty in the width, which is 0.08. 0.08. I divide it by, what am I dividing? By the measured value of the width, which is 3.12, plus, I'll come here, uncertainty in the height, which is 0.01. 0.01. I divide it by the measured value of the height, which is 2.94. 2.94. So everything I get here will be multiplied by V sub 0. That's the meaning of this. So I multiply everything by 51. Okay, and if we multiply everything here by 51, we're actually going to have around 1 point, that will give me around 1.83 approximately. 1.83 approximately. If we multiply everything in this bracket here, if we solve everything in this bracket and multiply by 51, we'll have approximately 1.83. 1.83. So that means that the whole of this part, the whole of this part here, the whole of this part is giving us 1.83. Okay, so the actual value of the volume here, the actual value of the volume here will not be given by this. So the volume we got is actually equal to, we got V sub 0 as 51. So this is going to be 51 plus or minus, this part is uncertainty, plus or minus 1.83. And then volume is measured in meter cube. So this is m raised to power 3. So the volume of the pool is 51 plus or minus 1.83 meter cube.